The video opens with a slow aerial shot of an empty desert at sunrise. The wind rolls across the sand, carrying dust in long, sweeping lines. And then, breaking the silence, a dark, angular silhouette emerges from behind a ridge. The Racer Heavy platform, an unmanned ground vehicle unlike anything else in the world. This is no ordinary robot. This is DARPA's vision for autonomous warfare, mobility, and high-speed resilience in terrain where humans struggle to survive. The camera moves closer as the RHP based on Textron's Ripsaw M5 unmanned combat vehicle accelerates across the desert floor. Its tracks bite into the sand, throwing dirt in a thunderous spray as it reaches speeds that no traditional combat vehicle attempts without a human in the driver's seat. But there is no driver, no crew, no one inside. The machine is thinking, sensing, correcting, predicting, pushing itself faster and harder than human reflexes allow. The narrator explains how DARPA launched the Racer program to create autonomous vehicles that can navigate extremely complex environments without relying on GPS or teleoperation. These machines must survive dense forests, rocky terrain, deep mud, narrow valleys, unstable slopes, and hostile weather. They must detect obstacles, map terrain, predict hazards, and choose safe routes, all in real time without stopping. The RHP rolls into a forested test range. High-speed cameras capture every turn, every shockwave as the vehicle climbs over logs, powers through brush, and maneuvers around boulders. Sensors mounted across the hull scan the environment hundreds of times per second. LiDAR slices through the trees, radar maps hidden contours, infrared cameras read heat signatures, and neural networks on board fuse all this data into a constantly evolving digital map. The narration slows to emphasize the technology. The RHP uses a brain built from cutting-edge autonomy software, algorithms trained on millions of terrain samples, millions of simulated miles, thousands of real-world test hours. This software allows the vehicle to interpret terrain like a human, predicting where the soil might collapse, where traction will be lowest, where shadows hide hazards, and when to shift speed to maintain stability. The video shifts to a DARPA test facility where engineers monitor rows of screens filled with live telemetry. They watch the vehicle's decision-making process unfolding in real time. Each sensor pulse becomes a point in a 3D cloud. Each frame of video becomes part of an evolving perception model. The engineers explain how the system doesn't follow a pre-programmed path. Instead, it chooses its own route dynamically, adapting to new information every millisecond. Back in the field, the RHP approaches a steep incline covered in loose rock. A human driver would hesitate. The vehicle does not. It calculates the angle, traction probability, slip risk, and momentum threshold, then commits. The machine powers its way upward as dust cascades down the slope. Dirt avalanches beneath its tracks, but the autonomous system constantly recalculates
The video highlights the mechanical power of the Ripsaw M5 chassis, electric drives, hybrid engines, modular armor, and a smooth suspension that absorbs punishing impacts. The vehicle hits a rocky section at high speed, but its suspension flows with the terrain, keeping sensors stable and data streams clean. The narrator explains how the chassis was originally developed for crewed and uncrewed experimentation, but DARPA chose it for racer because of its unmatched agility. Next, the scene shows the RHP weaving through narrow canyon walls only inches wider than its track base. This test simulates environments where armored vehicles cannot rely on satellite navigation due to signal loss. The RHP must operate using only its onboard perception. The machine inches forward, scanning the canyon walls with laser precision. It occasionally stops, adjusts its angle, recalculates potential contact points, and proceeds like a cautious but confident explorer. The video cuts to engineers loading new software into the onboard systems. They explain how each test helps the AI learn not just what to do, but what not to do, where common pitfalls occur, how terrain changes react differently at high speeds, how shadows distort perception, and how real-world physics break ideal assumptions from simulation. Over time, the vehicle becomes more stable, more aware, and more efficient. Now the RHP is shown racing across an open field at maximum speed. Dust explodes behind it in massive waves. The onboard AI predicts terrain irregularities seconds ahead, adjusting power distribution and steering faster than any human could. The narrator states that speed is not just about covering distance. It's about surviving in environments where lingering increases risk. The camera shows how the RHP reacts to an unexpected ditch. Instead of stopping, it measures the ditch depth, calculates a crossing vector, shifts torque, and performs a controlled leap across it. Engineers cheer as the vehicle lands.